Hey there, I'm Cahlen Lee, the modern day wizard, and you're watching The Wizard Life. Today I'm going to be installing a battery management system, this little thing here, also known as a BMS, onto this lithium ion battery pack which I made. Now this is about a 12 volt battery pack, and which is pretty similar to what you would find in your car. And in order to get it up to that voltage, because each cell is actually quite a bit lower than that, I have to run parallel battery packs in a series. So one cell is 4.2 volts at its max, and then I run a bunch of them. You can see there's this group here. This whole group here is called a parallel group, and they are still all 4.2 volts. And what they're doing is they're kind of adding to a single pool of capacity. So the amount of power that's in one cell multiplied by 12 is what this thing is doing right here. And then I actually have two other groups here, and that the three groups together gets me up to 12.6 volts, because one group is 4.2, and then the next one's 4.2, and the next one's 4.2, and that gets me up to 12.6 at its max. Now the downside of doing this without a battery management system is that, like this group right here where the energy is flowing out and then the energy is flowing in over on this side, it causes that these three parallel groups to actually end up at different voltages, and those voltages end up being quite a bit different over time. That can be dangerous because when you're charging it, you might end up getting one of the groups above what the capacity of one of these things is, which can lead to a fire. And you can also get one of the groups down below what their minimum capacity is, which makes those batteries useless forever. So I don't want either of those things to happen, which is why I'm going to install the BMS, or battery management system, because this thing is going to kind of be in touch with each of the groups and make sure that each of them has the same voltage. So before I move forward with installing the BMS, I just want to show you what I mean by the imbalance in the voltage of this battery. First, we're going to use this multimeter, which is a tool for testing voltage. You can test a lot of other things too, but that's voltage is what I'm going to use it for. And I just need to touch these cables to the positive and negative end of the battery. So here's the positive and here's the negative. And you can see it comes out to 11.42 volts. Now remember, this thing can go up to 12.6, so you can tell that I've been using this battery a little bit. And now let me show you the actual issue that is caused by not having a battery management system. So this is a parallel group right here, and then here's another one, and then here's another one. Now every single cell in this parallel group should have the same exact voltage. So let's just verify that. 3.95. So remember, one cell can go to a max of 4.2, so this cell is actually nearly full. Now let's just verify that the other one in the same parallel group is the same voltage, 3.95. So this cell is this parallel group here is pretty close to full. So let's check the next one, the middle parallel group. And I'm going to switch because the batteries are upside down in relation to this one. So negative on top here, and we're at 3.84. So that's a little bit lower than this other group. Now let's check the last group. 3.62. So getting pretty far down there. So the first step is to do some soldering. So I need to get some wires hooked up to this thing, and then I'm going to attach the wires to the battery pack. And this will be the first wire that I hook up, which will just be where I will plug something in to the entire battery. So it's basically the input and output of the battery. And that will go on these two spots right here. So the P plus and P minus. So in order to get that actually attached and in a way where it's not going to come off, I need to use solder. So I'm going to use a soldering iron. This is just something you can use to melt this solder wire, which is, I think, nickel and silver and copper. And this stuff is solid at room temperature. And this tip right here will get really hot, and I'm just going to touch this wire to it, and it's going to become liquid and kind of stay on the tip. And then I'm going to touch it to where I want the wire to attach to, and as soon as I release this iron from it, it's going to solidify and be solid like metal again. So let's just see what that looks like. So the soldering iron is all heated up now, and definitely would not want to touch that tip. I'm powering it through this inverter here, which is running off of this 12 volt lithium iron phosphate battery for basically lawnmowers and stuff like that. And this is the wire, so I'm just going to touch the wire to the end here, and it will melt onto the tip and kind of stay there. You can kind of see there's like a drop of metal there. That's liquid metal, and I just touch it to where I want the wire to stay attached. There you go. Let's see if we can get a close-up of that. Now that wire should not come out and will be electrically attached to that part of the circuit board. So I'm just going to attach all the rest of the points now. So I've got them all soldered now. You can see this thing just looks like just a mess of wires, but got everything attached with solder. Now I need to place this on top of the battery so that I can start connecting the wires to the battery. But because I don't want to short circuit anything, I'm going to put some duct tape on the bottom here so that none of this metal is coming in contact with the actual metal on the battery itself. Got the BMS on top of the battery now. It's not in its final position because I still need to put a layer of duct tape over the top and bottom of the battery and then over the top of the BMS to secure it. But before I do that, I'm actually going to make all the attachments. So I'll show you the first attachment. Here is the B+, and that needs to attach to the positive end of the battery. So that's this whole parallel group, but I can just attach it at this point. So I took off this bar here, which was sitting right here, and that allows me to get underneath this other bar. Just slide it underneath there, and now I can put the bar back on there, press it down, and get this tiny little nut here, and then screw it on. So it's nice and tight, won't come off. And now I just need to do that for all the rest of them. Got it all hooked up. You can see the wires all going to the right places now. And the next step would be just to apply duct tape to the top and bottom and then secure the thing. But first I want to make sure that I've actually got this thing set up right, and to test that I need to test the voltage as it's coming out here because it's going from the battery into this thing, going through various circuits and coming out here. So let's just test that real quick. Got the multimeter up again, these two things, and I'm just going to touch them to the wire, the metal points inside here. So I got the positive and negative. And the battery's reading at 11.41. I think that's probably pretty close to what it was before. So I'm going to go ahead and duct tape this up and then get it charging, and we'll test to see if it actually balanced it. In order to charge the battery, I'm going to use what's called a solar charge controller. That's what this thing is. This is a very cheap solar charge controller. You can get this, I think, for $20. Other ones can cost you hundreds, and there's advantages to using those, but I'm basically using kind of a makeshift system anyways. This thing's not supposed to be used with lithium ion, and I'm also not going to be using it with solar panels right now. I'm going to be using this cigarette lighter type thing where I cut off what was on the other end and just expose the wires, and I'll plug it into this, and this thing will think that it's solar panels that are charging it. So here's just a quick demo how this works. You can see I've already plugged in the other end of this adapter into this thing. You can just plug it in, and now the battery is connected, and you can see it's saying I have 11.3 volts. Now, in order to get the cigarette lighter attached, I just need to plug in. So there's these little screws here, and you have to loosen them. These are the part. This is the section where the solar panels will plug in. So I'll plug the positive end in here, and I'll screw that in, which will tighten in. I won't be able to pull it out, and then I'll attach this into that as well, and I'll tighten that, and then it's good to go. So you can probably hear I've got the truck running, and just need to plug this in and it'll get charging. You can see it went up from 11.3 volts to about 12, and you can see the little arrow is flashing there from the solar panel icon to the battery icon. So I've set this so that it should only charge up to 12.6, so once it gets to that point it will stop charging. And since I'm off grid, this is pretty much the only way I can charge this right now, so I'll just have to leave the car running and come back once it's fully charged. Alright, a few hours later and the battery is fully charged. Forgive the poor lighting because it's dark now and I'm just using my flashlight, because this is actually how I usually run my lighting, so I don't have any right now. So let's just see what the voltage on this thing is. Right, 12.61, that's about right on with what we want. We want it to be 12.6. And let's see what each of the parallel groups are. 4.19, so that's pretty close to what we want. We want 4.2. Check the middle group. 4.23, now that's a little bit high, just barely, and it's not quite the same as this group, which was our goal, so let's see what this one is. 4.18, so this one's a little low too. So considering how far off the different parallel groups were in voltage at the beginning of all this, I'm actually not surprised to see it off by a few hundredths of a volt. I don't think this the BMS was designed to deal with a battery pack that was already out of balance. It's actually, I think it's meant to keep it in balance through charging and discharge. So it seems to be doing pretty well considering it's not really what it's designed for. The real test though is how is it going to do when I actually start discharging it. So next I'm going to hook it up to my 50 watt light, leave it there for about an hour, and then we'll check to see what the voltages are. So I've got the battery pack hooked up to the lighting system now. As you can see, the voltage is 11.7, so quite a bit lower than it was a moment ago, and that's what happens when you have a draw. You actually drop the voltage down instantly, and if I were to turn off the light it would go back up to nearly 12.6. Now I have some cables coming out here, and those go to a female cigarette lighter right here, and then a male cigarette plug plugs into it and goes up to the halogen and LED lighting system. So the one on the left is halogen, it's 50 watt. It's more like daytime light or sunshine. And the one on the right is red LED, draws very little electricity, and also it lights the yurt at night in a way that doesn't make my brain think that it's daytime, so I can go to sleep when I need to. So I'm just going to leave this going for about an hour and then we'll check in. Alright, the moment of truth. The battery's been running the lights for about an hour, so let's check out the voltage and see what it's at. Let's first check the overall voltage of the battery pack. So after an hour of running both lights, we're down to 11.48 from 12.6 when we started. Let's check each of the parallel groups. So this group is down to 3.64. Middle group is... Ooh, they're not the same. 3.87. And then last group... Wow, really big difference, 3.95. So that's the sort of imbalance that I would have expected to see before I had installed the battery management system. So I did a little bit of research just now, and it looks like, and I could be wrong about this, but it doesn't actually balance things while it's discharging. It just balances things when it's charging, and it also has a benefit of if one of the parallel packs gets so low that it's reaching the minimum like safe range for a cell, which is I think is like 2.8 volts or something like that, then it cuts off the entire thing. So, but it doesn't prevent them from getting out of balance during the discharge. So, looks like the battery management system is going to help me in that it's going to keep things balanced and keep us parallel packs from getting overcharged, which is good because I don't want things exploding or causing fires. And it's going to turn off the power when I'm getting so low on one of the parallel packs that it's probably going to damage them permanently. But it's not going to keep it balanced while it's discharging. And I'm guessing that it's probably not normal how out of balance these things are getting in such a short amount of time. So if there's anyone who happens to know why that might be happening, I hope you'll let me know. And I'm also going to do research in the meantime. All right, well, thanks for stopping by and checking out what's up here at the yurt, and I hope to see you next time.